electrical safety. Okay, so first of all we will discuss about what are the hazards of electricity. Okay, so what are the hazards of electricity? You know, in electricity we talk about two terms, which is voltage and current. Voltage is the potential difference between any 2 points. Difference between 2 points. Okay, it is represented as V, unit is volts. Okay, similarly current. Current is nothing but the flow of electrons. Okay, current is represented by I, which is in turn amps. Okay, and we have resistance. Okay, any material will have at least bit of resistance. Okay, resistance is just opposing the flow of current. Okay, resistance opposes the flow of current. It is indicated as, unit is ohms. Okay, or if we want to indicate resistance in a circuit, we will indicate it as R. Okay, as per Ohm's law, we know that V equal to IR. Okay, voltage equal to current times resistance. So by using this, we can find out wattage. What is wattage? Is the power consumed that by that particular equipment. Okay, so wattage is equal to voltage into current. Okay, V into I. So watts is the unit of wattage. Watts, kilowatts, megawatt. Okay, this is the unit of watts. Fine. Now if we will substitute wattage equal to voltage into current, so as per Ohm's law we can rewrite this equation, V is equal to IR, right? IR into I equal to I square R. So even though if you have current, we can find out current, or else if we will substitute voltage, V into V by R, that is equal to V square by R. So if we have current and resistance, we can find out wattage. If we have voltage and resistance, we can find out wattage. Okay, simple, right? So next we will see, the higher the voltage, the more dangerous it is. Okay, in electricity we have two type of currents, which is, one is alternating current and second one is DC current, direct current. One is alternating current and DC current. In alternating current, we have the current will flow in sine wave. Okay, in AC, okay, the flow of current will be in sine wave. The pattern will be as sine wave. Okay, so this is how the current will flow. Okay, if it is DC, it will be constant. Okay, the flow of current is constant. I mean, it will be like, this is the current in DC. Okay, this is the current in AC. Okay, so here we are having phase difference. Here we don't have any sort of phase difference. It is just peak voltage that we will be having. Okay, so next, the more the voltage, the more dangerous it is. Okay, remember these things. Why? We will discuss when we are discussing hazards. So what are the hazards? Electrical hazards. Okay, what are the electrical hazards or hazards associated with electricity? Remember these particular what do you say, synonym or short form? Okay, remember, be safe. These are the hazards of electricity. How be safe is hazards of electricity? B, burns. Okay, E for electrocution. Okay, S for shocks, A for arcing, F for fires, E for explosion. So these are the hazards of electricity. Okay, So burns, because we know if we get in touch with any sort of electrical wire which is already amps will be flowing and it creates heat. Okay. So when we are electrocuted or we are getting shock, okay, because of the high heat our skin will burn. Second thing is electrocution. What is electrocution? Passing of electricity through any part of a body is electrocution. Electrocution means not only in the sense of getting shock, but passing of current from the body or any metallic part. Okay. Next is shocks. What is a shock? We feeling it now. Okay. Shock is the current passing through one part of a body to other part of a body, and we are having effect. Okay. In electrocution we are not having effect. In shock we will be having an effect. Okay. So in case of shock, what sort of effects we will have is, first, if the current is more, the voltage is more, then the person will get burned. Okay. Apart from the burn, we have two side effects which we will have. One is shivering. Okay. The body will shiver. The person who has got shock will get shivering. Second thing is we will have ventricular fibrillation. What will have? Ventricular fibrillation. That means, see, the whole our body will work on a particular frequency. Okay. By which the heart is beating, right? Heart is having certain level of frequency. So when we are getting a shock, mostly this frequency will subside. When it is subsiding, so the body cannot work with the same frequency. So what happens? All the nerves will contract. Normally they will contract and expand in the same, almost near same frequency as our heart. That will slow down, that function will slow down. That will cause to ventricular fibrillation. So what will happen? Same, again the consequence is more or less the shivering only. Okay. And he will get even heart stroke or heart will cease to work. That is one possibility of shock. Okay. Right. And next is arcing. What is arc? What is arc? Electricity, see, the voltage is like water. Water will always flow from high region to low region, correct? Will it flow in a reverse way? No. Water will flow from high region to low region. Similarly, in electricity, this voltage, okay, voltage will flow from high potential to low potential, high potential to low potential. So what will happen if for example here now I am having voltage, okay, I am trying to increase this voltage step by step. It is increasing. I am raising the voltage slowly. So here voltage is getting built up. What will happen? Now here voltage is getting accumulated and it always look for a source to jump. Okay. So now at a certain point it has gained sufficient strength to jump. No need to make an contact. No need to make an contact, it has gained sufficient strength to jump. When this is jumping, okay, the resultant light which is produced is your arc. Okay. So arc is produced and the voltage will pass. Okay. So this is the concept of arcing. So voltage will always try to jump when the contacts are near. Okay, when it has got sufficient potential. Now what is the sufficient potential means? If you are taking capacitor, battery or any sort of thing, we will have, okay, the medium which is called dielectric. Okay, dielectric medium, right? So this potential will be so high that it will be able to break this dielectric medium and jump, create an arc. Okay. Got it? So that is how the voltage jumps. It breaks the dielectric and passes from higher potential to lower potential. The best example is lightning or thunders, lightning. So lightning, why all lightning will not reach earth? Because not all lightning has a potential to break till break so that it can come to ground. Only few few lightning has that potential and it will come to ground. Okay. So this is what you have to remember. And second thing is, this arcing concept will be used in welding. You have seen welding, you can see TIG welding, MIG welding, any type of welding, the basic concept is getting an arc. Why? When we are having an arc, two things will happen. High amperage will flow at a time and high heat will be produced at that particular point. When the high heat is produced, it will be able to melt the filler material and it will make the weld. Okay. So the same process is used in welding. So even in welding, this is the major concern. Okay. Always you should have return lines. Okay. We have two lines. One is incoming and one is return. So this return line should be completely closed. If it is not properly closed, it can find out a way through a human body. That is the one concern of getting a shock in welding. Okay. So this thing we need to take care. And second thing is fire. Through electricity we can get fires, okay, and explosion. For example, flammable substances are there, it is ignited and it can explode as well. Okay. So this is the concept of electrical hazards. So what we need to do? What are the control measures? What are the control measures? Control measures, first thing is, see, inspect all equipment. Okay, inspect all equipment. Periodically. Okay. Once this inspection is done, you have to so mainly the cause is because of improper wiring. Okay. So check termination of cables is proper or not. Okay. Once this termination of cables is proper or not, and check for loose connections. If there is a loose connection, there is a possibility of getting an arc, okay, and a fire. Now apart from loose connections, you should not overload the circuit. Overload circuits, okay, do not overload circuits, okay, and prevent short circuits, okay, prevent short circuits. And after that we need to have proper maintenance, okay, and reverse connections or reverse polarity to be avoided. What happens if I keep plus to minus and minus to plus? What will happen? It will explode again. Okay. Reverse connections and reverse polarity to be avoided. And next thing, use PPE, personal protection equipment, safety shoes, rubber gloves, okay. And always see, there is a stored energy. The concept of stored energy is, be it mechanical, electrical, chemical, okay, or thermal, the energy will be stored, okay. So until and unless it is discharged, there is a potential that we will get a shock. Now if you switch off a TV, there is an LED which will blink for some 10 seconds or 20 seconds. Why it is blinking? Because of stored energy, okay. So what we need to do is, we have to make sure that discharge, okay, discharge the stored energy by discharge rod, okay. We will have discharge rod, especially high tension lines, or when you are working in power plants, circuit breakers, okay, we have to discharge the stored energy. So when we need a discharge, when we switch off the power, go for discharge directly. So simply there is a discharge rod, you need to connect it to earth, okay, and you need to connect 1 and 2 the all terminals, it will discharge, okay, and check the voltage if it is properly discharged or not. And proper earthing should be there, proper earthing should be there. Earthing is for personal safety, earthing is for whose safety? Person safety, okay. So more or less these things, but if you have any things in mind, you can just add it up, okay. Okay, next, next is okay, we have earthing, we have done we discussed earthing, okay. Next we have some safety elements, which is fuse and circuit breaker, okay. Fuse is a weak link, okay, weak link which will melt if there is overcurrent, if there is overcurrent, okay. So circuit breaker, it trips the circuit, okay, if it senses overcurrent or voltage, okay. So most of the time fuse is a very old concept, but you can still see it in some kind of equipments, laboratory equipments and all, fuses will be certainly there. So this link will break off, what will happen is it will just melt down, preventing power supply, finish. But it has to be replaced. There are advantages and disadvantages, I want you to go through those things, but these are all safety devices for any sort of electrical equipment, these for our protection, device protection especially. So circuit breaker, what it will does is it has its own ampere rating, okay, like you see 6 amps, 10 amps and 20 amps ratings will be given, okay. So if it attains that rating, it will automatically trip off, especially if it is a short circuit, then it will trip off immediately. Short circuit, we will have high amperage, okay. So these are the safety devices that we use. And second thing is we have GFCI and ELCB, okay. GFCI is ground fault circuit interrupter, okay. Interrupter. And ELCB is earth leakage circuit breaker, earth leakage circuit breaker. And we have RCCD, which is residual current circuit, RCCB, okay, breaker. This is used widely now, okay, because of its application it is used widely. So what it does is ground fault circuit interrupter will always try to sense if any see, normally it happens because of leakages that the voltage or current is passing through the body. So it will sense the leakage, if it is passing through the ground, then it will try to interrupt the circuit, it will cut off. Second thing is we are having a earth leakage circuit breaker, it also does the same thing, but it gives better protection than GFCIs, okay. Then comes the advanced thing, which is RCCB, residual current circuit breaker, which also does the same thing. It senses current, okay, residual current, which is leakage current, and it will trip off if it senses that it is, I mean, it is accumulating or it is not, it is reaching to the ground, okay. It senses and it trips off the whole circuit. So the main thing is operation of these particular devices will be in the range of 0.30 millisecond, okay. Sorry, I mean less than a second, not I don't want to say specify the time, it will be in the range of, okay, less than 1 second, mostly milliseconds only, but I just don't want to specify the time. So within less than 1 second it will trip, okay. It will sense a current of 0.35 milliamps, 0.30 to 0.35 milliamps is your sensing current. Okay. Why it is 0.30 and 0.35? Because 0.50 milliamps is lethal for us. 0.50 milliamps is lethal. So that is why it has to sense and trip if the current, leakage current is more than 0.30 milliamps or more than 0.035 milliamps. Okay. So here we have two concepts. Normally what happens is, no, this concept is related to human body. When you are in direct contact with the wire, okay, and you are electrocuted, you are in a state of shock up to certain voltage. Okay, that voltage is called let go voltage. Okay, let go voltage means you will be able to free from that particular connection. Okay, if the voltage is more than that, then you will not be able to leave, you will hold on to wire. Okay, so that let go of voltage is also important. So just go through it, try to get some information on that let go of current. Okay, so this is the concept of electricity. I mean cables, you just need to ensure proper insulation. Okay, the joints should be tight, use always industrial grade connectors. Okay, especially when you are choosing connectors, choose the ratings properly. If you are working in an hazardous area like zone classified area, we need to use zone classified electrical equipment along with the connectors, FLPs, be it FLPs or any sort of electrical equipment, motors and everything has to be that area rated. Okay, so check for that area ratings. Okay, so any doubts? Electrical safety is clear. Okay, I am just trying to keep it precise and short. Okay, I am not going too deep.